Hello everyone, today we will be speaking about randomized branch sampling. But first, I have to remind you to engage and rate this session. And so what is the purpose of speaking about forecasting project size? So when we start software development, at least in my experience, the two questions that I hear all the time are how long and how much. How long will it take and how much will it cost us to deliver a piece of software? And in order to be able to answer those questions, we need to know how much software we will be delivering, right? We have to have a way to quantify this how much. And usually that's we call it like sizing. So sizing in this presentation, in this context, is like for us to be able to quantify the size of the project, a piece of delivery, and not to forecast the effort needed for delivering. So these are two different because usually when we say sizing, we usually think it's about how much time, right? That's unfortunate, I would say. And that's what I want to emphasize on, that size estimates the probable size of piece of software, while effort estimation estimates the effort needed to build it. We'll be speaking about sizing here. In Agile, we usually use t-shirt sizing and story points, although initially, back in the previous century, when they started with software development, they were using lines of code written, and then it was function points analysis, which actually even made it to be codified in several ISO standards. But again, in Agile, we are using t-shirt sizing, story points. T-shirt sizing is very easy to start with, especially for immature teams. One thing with t-shirt sizing is that it's not additive, like readily additive. We can add it up by substituting sizes with numbers, but it's in short, it's difficult to say that our project is big, like 2 M's, 3 L's, and something like that, right? That's why most of the times people we are using, at least people are using story points. And story points here, as presented by Mike Cohn, for instance, he claims that story points are about effort, about time, about hours. Again, in this presentation, we will be using like size and story points only to mean complexity, in any way complexity, right? But not about hours. So when I say story points, it will mean relative size and not relative effort. Okay, that's just in the context. Although I know people that actually claim that Mike Cohn's definition is not correct at all, and but it's depends on the team. So for us, like, because software sizing is different from software effort estimation, when I speak size and story points, it will mean more or less complexity. In Kanban, what people are doing, they are sizing in just counting the number of stories, for instance. Some people use they count the number of tasks. But in general, whatever we count, it is the way it is supposed to be done is we have to identify all, like we have a product or a piece of software that we need to deliver. We have to break it down into epochs or bigger chunks, and then we have to break down each epic in stories, and then we have to analyze each of those stories into story points, and then we sum up and we end up with the total size of the project, which is time consuming. But not only time consuming, it's really most of the time it doesn't make sense because requirements change, context change. And it will not worth the effort, right, for analyzing a bunch of uncertainties, right? And especially when we have to make portfolio level decisions, for instance, which projects to work on, to accept, to commit to, or to make quotations to our customers. Like spending such an effort, it's people don't do it, literally. And that's why I was looking for a way to speed up this sizing activity. And I, thanks God, I found like a technique which is originates from horticulture. As strange as it is, I'm not sure why it's moving, but I have to move it back all the time. The slides. Yeah. So this gentleman, it's called Raymond Jessen, and in the 50s and 1950s, actually he established a method for a technique for efficiently for estimating the total number of fruit found in the canopy of a tree, while counting a select part of the canopy. So it is a method still in use today in horticulture, although they don't use it for orange trees as originally. They use it mostly in estimating the total biomass of trees, including like everything, not only the fruits. But it's still being used, mostly in Europe. I would say like people are interested in biomass or something like that. But anyway, it's very useful. It is multi-stage unequal probability sampling, which is I will in the context of this presentation I will not focus on the math. I will focus on the applications. The math you will be able to read if you are interested in there is an article in InfoQ, and I'll show it at the end, and all the math is there, right? So here I'll just focus on the applications. I'm not sure what. Most of the time people just don't like math. Anyway, so what is the idea? So the idea is that we present a product backlog as a branching system. So that's a fictitious product. So we have some backlog. We have broken it down into 3 epics, A, B, and C, and epic A has 2 stories, epic B has another 2 stories, epic C has another 3 stories. So that's a fictitious product backlog, and it's a branching structure. And because it's a branching structure, we can actually apply RBS to this structure. This is the math. It's called Horowitz-Thompson estimator. And it works by computing the unconditional selection probability for terminate shoot, which means that if we start from the trunk, which in our case is product backlog, and we just pick a path inside the branching structure, inside the tree, and we calculate some probabilities for a terminate shoot where fruits are located. That's in short, right? And it's how it looks. It's so we have this kind of a structure, which we have the product as the trunk, and then the epics, let's say, are our branches, and then the terminal shoots are where the user stories are. And the fruits in our case might be story points, tasks, whatever you think of, right? And what it does actually, it expands the size of the story multiplied by the size of the epochs in order to find actually the total size of this rectangle. But again, let's not focus on the math here. What's important, and that was the main question when I actually started playing with data using RBS is why RBS works for sizing software development projects. So this question stands because when they apply it in horticulture, they estimate something which is there, right? You go to a tree, and the number of fruit on the tree, in the canopy of the tree, has an objective value, inherent, abstracted from its interpretation, objective value, a number. Well, there will be a counting error, right? If we count all the fruit, but more or less it's the same number, right? When we apply RBS to our product backlog, there is nothing there, right? There is nothing. This size, as we call it, is a proxy for all the functionality and capabilities that we will be delivering eventually in some future point. You see the difficulty here, right? How to apply so the question is from what universe we are sampling. There is nothing there, right? And then when I apply it, like I used real data, and it showed that actually it's applicable. And here is my explanation, right? So the assumption behind using RBS for software development is that the project size depends on the context, and the context is a very broad concept, but it includes the customer, the people developing the product, and the methodology they will be using when breaking down the product into epics, stories, whatever they do. And if there is such a methodology and they apply it consistently, and the methodology itself is cohesive, again, that's a very important look, it's cohesive, then somehow, and that's you see with the data later on, somehow we are able to find something tangible in the future, because people are applying consistently a cohesive methodology for breaking down an idea into chunks. So that's the difficulty here. If you have just an idea and you have no data to prove it, right? It's nothing, right? I mean, it's just a fiction. And I'll show you some applications. So the most important application, I'm not sure what it is doing this, but the most important application, at least the one that I find it the most important, is to check if our team is applying the methodology consistently. So if we follow this idea that we are actually checking an application of a methodology, and the methodology doesn't matter what the methodology could be. It could be planning poker. It could be behavior-driven development. It could be feature-driven development. It could be even probably function point analysis, right? If there is a methodology, and you see with the data, we can actually claim and check if the methodology had been applied consistently. So the first application is that if we have some historical data for our team or teams with sizes, let's say they are sizing each and every sprint, and we want to check if the team members actually are not generating random numbers for the size, but are doing something, right? Thinking and sizing, right? We can use RBS to check this. We can use RBS to see the effect of a coach for instance. If we hire a coach to teach our team into planning poker, we can compare before and after, because we are comparing. We are sampling from an application of methodology, and here I might get in something like a bit like a fairy tale, but you'll see the data later on. So that's one very important application. And what I did last year, I have friends at Scrum.do. Scrum.do is a tool for managing Scrum projects and Kanban projects, but mostly Scrum projects, Scrum-bound projects these days. And I asked them to provide me with some random data. So they have plenty of teams there. Plenty of teams, plenty of projects, and they were able to reach an agreement with some of the teams so that we can use the data, right? Of course, it's anonymized, right? But so we actually got 13 real projects from 13 different teams, and I'm not sure what they are doing. I really don't know what they are doing. But what is common for this project is that all projects, they have epic story task breakdowns. They have successful release history, and they are stable teams, so they work for a long time together, and they have an active Scrum.do coach or Scrum master. This is very important, because remember, we are discussing here application of a sizing methodology, right? So they have somebody there which actually is guiding the team and actually controlling this. These are commercial projects, and they have like a minimum size of 12 epics, right? So that they are not that small, right? So see, these are 13 randomly picked projects. And what I did, I got the data, so they have their sizes for releases and sprints, and I decided let's run RBS on their real data and compare the estimate, the forecast, with the actuals, just to see if actually there is something in RBS, right? So that was last year. So see here, that's sorry. This is in stories. Oh, okay, story points. Not sure why it is doing this. So here what we have on the x-axis, we have the estimated project size in story points for those 13 projects. On the y-axis, we have the actuals. So again, what I did, I took the actuals, I sampled, which means I picked using RBS only a small subset of all the user stories those teams sized last year. I got a size for each of the projects, and I compared the estimated size with the actual size. And here, well, it's math anyway, but you can see this R squared over there, like it's called correlation coefficient. And if it's close to 1, it means a very strong correlation. So here we have 0.97, which shows a very strong correlation, almost like impossible, if like it's a really strong correlation. Again, these are 13 different teams, 13 different projects. I really don't know what they're doing. And it shows that all 13 teams have a very good application of a certain methodology for when they size their projects. I really don't know what they are using. I haven't, because the data is anonymized, I cannot go and ask, right? But that's not the point. The point here is that, because again, if we get back here, so these are stable systems. They definitely apply some methodologies. They have a coach to guide them. So they are stable and they do something on purpose. It's not random numbers, definitely. These are not random numbers. So again, this is one of the applications. So if you have teams or a team with a certain history, release history, very easily you can actually check if they are applying something or they are just like, well, we always assume that people are doing their best and they are not cheating, right? But when I say consistent application of a methodology, you may not apply it consistent because you are not well trained, right? You just don't know what to do. So we are not speaking cheating here. We're just comparing what the people are doing and if what they are doing is consistent, whatever they are doing. So if you have teams with release history, you can check. If you have teams and their release history, let's say it's not like the correlation is not that strong, and you may think about training them, you can check after the training what the effect is. Now, because these teams actually they had also they used tasks, and this is the correlation when we estimated the number of tasks with the actual number of tasks. And you see the correlation coefficient here is not that strong. It's only 0.93, let's say. Again, it's a very strong correlation. And the first thing is like the number of stories. Because again, in some teams like in Kanban, we just count the number of stories. And I run RBS to see if the actual number of stories will correlate with the estimated number of stories. And again, very, very strong correlation. So what this means is that by using RBS with a simple sampling, we can very much forecast the size of a project deliverable. And again here, and I have data to show, it's not only about projects. It can be applied even if you have a release, no epochs at all. Let's say 100 user stories. And it works the same way. Because it's again a branching structure. We have a release is the trunk, and all the user stories are the terminal shoots, right? And actually I used Jesper's data for this because it, so this is one of the applications, right? So these are the conclusions from Scrum.com data. First of all 13 teams consistently applied a methodology for slicing the requirements into user stories and sizing them using story points and tasks. That's the conclusion. So very good for all those 30 teams. Then the quite important conclusion is that they somehow managed the emergent and high change risk requirements. You know, when we start a project, the scope usually grows, and some people call it like scope creep. Other people call it like learning. Yeah, but anyway, the scope usually gets bigger. So they somehow managed. And the third and most important conclusion is that execution is more important than planning, because here with RBS we don't speak about like planning on a daily basis. We use RBS only for, let's say, on high level or a budget level planning, right? In order to make a portfolio level decision, again, quotations, to check if the teams are consistently applying a methodology and things like that. We don't use RBS when actually we start executing the project. But the team, if the team is really agile and actually they don't start with a full backlog or let's it's like a batch of work, right? It's the team that will have to continuously and consistently apply the same sizing methodology. And that's why execution is more important than planning. This is just planning here, right? So here, don't think that it's like that's the holy grail or anything like that. It's just a very useful tool to start a software delivery or to compare different sizes. Again, if they come from the same team, right? But it is at this level, like it's very high, and then it's up to the team to deliver, right? And then, of course, the next application is for sizing new projects. And we can size, for instance, we can estimate the total number of user stories in a project. So in Kanban, usually that's what we are interested in. We're interested in the number of stories. We can then apply RBS for estimating total story points, as I showed. And then we can apply RBS for estimating number of tasks. And we can estimate the number of BDD scenarios in the project. That's what I'm using it for, because when my teams usually they use scenarios, which is almost the same, right? I mean, that's the same idea. We can apply it to. I don't have data for function points, but I'm pretty sure that it will be applicable there as well. If somebody is using function points, I know people are using it. At least in the United States, in GOD projects, it's mandatory to use function points. And here, like a bit of math, right? Just to show. I have 30 minutes, so we have plenty of time. So again, here we want to estimate the number of stories in our project, and we have a product, and then we have an we will break it down into epochs, and then each epoch we will break it down into user story, and that's our branching structure. And it's like just for the sake of clarity, that's the same structure, right? So we have an apple tree, and we have the trunk, and then we have branches, and what we are interested in are the terminal shoots, which are the small branches with the fruit on them. That's the mapping. So product is the trunk, epoch is the branch, and user story is the terminal shoot. And here is the formula, right? There is no need to remember the formula again. There is an article in InfoQ, and I'll show you some Excel stuff. But so it's a very simple formula in order to estimate the number of user stories. We actually we follow this particular algorithm. And why it's moving? Okay. So first we divide the project scope into epochs. So that's mandatory. So if we have a product or a project that will have 1,000 epochs, we have to know there will be 1,000 epochs, right? If we have this structure, which is product backlog, epochs, stories, right? So we have to find the number of epochs. That's it, only the number, without any analysis, just the number. Then we randomly sample one of the epochs, which means really at random. So the key word here is at random. So we cannot sample the most riskier or the easiest or whatever we want. It has to be at random. So random means at random. And then we analyze how many stories are in this epoch, which means that we have to break down this particular epoch into stories. Just break it down. And then using the formula I showed, we calculated the estimate of stories. So this is for stories. And then we repeat the points from 2, 4, 7, between 7 and 11 times. That's 7 usually works. And then we can estimate like the same RBS applied for estimating total story points in a project. Again, this is our branching structure. And here what we have is like we have the project, then the epochs, then the user stories, and then we have the fruit at the bottom, which are the story points. And then again, that's for clarity. So the mapping here is trunk is the product, the branches are epics, user stories are terminal shoots, and story points per story are the number of fruit on the shoot. That's how actually these are the algorithms used for the Scrum do data. The same, and I'll show you in Excel how it can be done. This is the math, and this is the algorithm. So we first again divide the project into epics. That's a mandatory step. And many people say, well, if there will be 1,000 epics, so it's a lot of work. Yeah, it's a lot of work, but is there any other way? I mean, if you go story by story, you'll have to break it into epics anyway, right? So if you have a project of 1,000 epics, it's a lot. But anyway, it will save you a lot of time. Then again, we randomly sample one of the epics. Then we analyze how many stories are in this epic, and we just write down the number of stories. And then we randomly sample one of the stories, only one of the stories for this particular epic. And then we estimate the story points for that story, only for this particular story. We have to analyze, we have to know story points. And then we use the formula, we calculate the project size for this particular epic, then we do it between 7 and 11 times again. And I'll show you right now in Excel. So what is the conclusion? So RBS is a sizing techniques for forecasting techniques for sizing software projects without prior identification, analysis, and sizing of every single user stories. Project size may be measured in story points, number of tasks, BDD scenarios, whatever, function points, whatever, as long as there is a methodology being applied. It can be used. We found, like by running RBS on a historical data, we found that there is a very strong correlation between the forecast and the actuals. Really strong correlation. And of course, using RBS, we can answer the question how much software we will need to deliver at some point. So here is the article, and I'll go there, just for you to see. So here is the article. You can go and read all the math. Here is a lot of math. All the formula is here, sample calculations. And then what's like the Scrum do data, and then what's important is here at the bottom. It's I'll show you the Scrum do data, and it is at the bottom when you click the link, and then you go to the bottom of this article. It's from their site, right? Because that's their data. At the end, it says the results, and it goes to a Google Doc spreadsheet. So all these 13 projects, if you want to check how it's done, again, it's anonymized, like Scrum project 1, 2, 3, 4, like you can go, and for each and every project. So here is the data. Right here is the data. Here is the calculation itself for each of the projects. Yeah, for each of the projects, and then we go to the end. No, to the first slide where the summaries, the results are. And so that's here are the results. Again, on the x-axis, we have the estimated size. On the y-axis, we have the actuals. So we have, it comes from this, the actuals and the estimate. And then see, they are not the same. See, the actual size is not the same with the estimated size. And it might be a disappointment to somebody. But again, it's an estimate, it's a forecast. And again, during the project execution, there most probably were new requirements and changes in requirements. But anyway, what's important is this, the correlation. It's a very strong correlation. So if you have, let's say, like 13 releases for a team, you can use the same Google Docs document, and you can actually send me a questions if you have. Like I prefer like direct messaging on Twitter. Because my mail address is very long. So my name is Dimitar Bakardzhiev. It's like it's impossible to communicate this. So Twitter Twitter is better. And you can see like but see what's the difference. Like the actual is 5733 and 0.5 story points. The estimated is 500. 297, 254. Here is a bigger difference. Here is a very big difference. Here is like for a very small project, it's almost no difference. See, but they are not the same. And we are not expecting the numbers to be the same. Yes? This point you mean? Well, it's done automatically. That's the point. 3040 something, 9000. Yeah, that's the point. Yeah. I have it in Excel as well. And it's the same correlation. I mean that it is what I'm not sure what, but it's the same correlation. I mean that the table comes, this diagram comes from here, and you can check it yourself. I can go to the article, then go down, then click on the Scrum.do link, and then go and see the data is there. You can check it yourself. If there is a bug in Google spreadsheet, then there is the same bug in Excel. Yeah, I can show it in Excel as well. So that's, again, we are looking for correlation, right? We don't expect the same numbers. It will be absolutely impossible. If the numbers were the same, I would be the first one to say it's a fraud, right? It's impossible to be the same. Only due to the fact that there are emerging requirements, it's impossible to have the same numbers. But we are very close. And again, this is not for detailed planning to bet your house on this. It's for high-level planning, right? Because if you have a new project coming and you are not sure can you fit it in your portfolio, and you can do this calculation for 10 minutes, literally. And again, budget estimates according to PMI 70% accurate. It's more than 85% accuracy. Again, for me, it's useful. Then what I'll show you next, yeah. So here is an Excel file that Martin Asprelli prepared based on the article. And I'll show you how easy it's to be done. So here he is probably using it in his own projects anyway. So we have the number of epics in this. These are absolutely random numbers, right? It's just for illustration the method. So we have 100 epics, and we will be estimating in story points. What we are doing here, you see the formula. We are picking at random one epic number. So we have 1, 2, 3, 4, 5 till 100, and we are picking one. Excel is picking one 11 times. So these are the epics we pick at random, which actually means that we have to have these 100 epics at least with their names in front of us, right? We have to have a list of epics. That's a mandatory step. And then, because the way Excel is doing, if whatever change I make, these random numbers will change, right? So what we are doing, we are coming here, we are copying this thing here, and we pasting only the values anyway, as if I am pasting. We paste only the values. And then we go there, and the next step is break down each of the sampled epics into stories. And for each of the sample epics, we are breaking down the epic into stories. So we are doing, first of all, so thinking from an effort perspective. So we have to first break the product into 100 epics, which probably we'll have to do it anyway, really, but that's an effort, right? And then For 11 of those 100 epics, we'll have to break it down into user stories. Just break it down. And then that's the estimate of the total number of user stories in the project. 1682. So if we have to break down the whole project just to arrive at the number of stories only, we will have to come, like, eventually we'll have to have a list of 1600 user stories. Now with a very, very limited effort, we arrive at the same number. Again, it's a forecast, right? It's a forecast. Execution is more important than planning, right? So now we have the number of user stories. Then we randomly sample one story from each epic, and again it's done in Excel, right? We sample just a number of the user stories, like 1, 2, 3, or 5, and here are the indexes of the user stories. And we copy and paste only the values so that Excel will not generate new numbers all the time. That's how it works. And then we go, and for each of the randomly sampled story, we only for that particular story we will do any kind of analysis or sizing or anything. Only for 11 stories in total we will be doing any kind of sizing. Up to now we are just breaking down, right? We are not sizing, we are not analyzing, we are just breaking. Although it's a process and it should be a methodology followed for this, but again it's not analysis, it's not sizing. And then eventually that's the total number. In this case it is almost 11,000 user stories. Again, these are fictitious numbers just to illustrate the method. If I put real numbers, it will be for a real project. Okay, so just think about just to come up with this number, what an effort would be. How many days? I really don't know. I've never done it, so I really don't know. Like estimating so many epics. Anyway, and that's the thing. We can do it the same if we don't have epics. If we literally don't have epics. So using the same file. So this time this is Jesper, one of the Jesper projects, and it had 92 stories of something. I really don't recall what. And again we sample this time only 7, right? I decided to be smaller number. 7 out of these 92 epics. Actually they are not epics, they are just stories or pieces of functionality, right? But because I'm using the same Excel file, it's right now it's epics, but it's just pieces of work. And then for each epic we say that every epic has one story, right? Which means that we don't have stories. And so that's the estimated number of stories, which actually is the same as the number we started with, which is expected, right? But that's not our goal. We want to know the size of this thing. And again, we at random, we pick one of them, which is again 7 stories. We analyze those 7 stories, only 7 out of 92. And that's the number of story points. So for that particular project, the actual number was 774. I know nothing about the project. Neither the project nor the team. I know nothing. So there is a difference, 5% difference between actuals and forecasted. Well, it is what it is, right? We cannot be on the spot. But it's 5%, quite good. I would say. So here we have 4 minutes for questions, I believe, right? I can take questions. We have 4 more minutes, right?
Yes, we have some questions from the Q&A. Most of them actually have to do with translating this into effort. So one of them is, since this is working for sizing, why wouldn't the same technique apply to effort?
Because when I use the data, the effort along with the size for any kind of project, I found no correlation between the number of user stories or the number of story points, especially between the number of story points and the effort or the delivery time. If your project, it's a very easy thing to do. Just plot the user stories for the project, like for each story, and then the time that it took to deliver. And if there is a correlation, then you can use the same method for forecasting the effort. If there is no correlation, which I bet there will be no correlation, unless you have a very small team with a very high flow efficiency coefficient, which is like Hakan knows what many people hopefully know, there will be no correlation. So I always try to be rigorous, and if there is no evidence that actually we can apply it to effort estimating, then I will say we cannot apply it. If you can do it, you are more than welcome. It will be a groundbreaking effort or event. But even the size as such is very important, right? And that's probably the answer to this question.
I think there's a very good follow-up question to that answer. It says, my managers really don't care about size. They care about hours. So will I gain anything from doing size estimates?
So I'll be running a forecasting workshop in Paris on November 2nd at Lincoln, France. So if you are interested to see how you can use the sizing and then estimate the effort and the delivery time, it's a different story, but it can be done, right? It can be done, but it's not for today. And there are other ways, like how I do it. I run Monte Carlo simulations based on historical data about delivery times, right?
Okay. Another question reads, how can I assess if my team works in a way that is suitable for RBS?
That is suitable for RBS? It's not suitable for RBS. Like it's just like it's the other way around. So. And that's it. That's a big question. I have personally experienced, like I go to a team and say, give me your data and I'll run RBS and I'll tell you if you are consistent. They never provide the data, right? Because the RBS is like a mirror, and it will reflect reality. If there is no correlation, which means that they are actually they don't follow any methodology, right? And the reality will be ugly. And we as humans, we don't like ugly things. We don't. So the main obstacle to of using metrics in general, my point is that people don't want to see the truth. So to answer the question, it is not that RBS is suitable. RBS will show, are you following anything? Or you are just generating random story points because somebody asks you to do this, right? Or tasks or whatever you do.
Okay, final question. How can you get an epic count of 1,000 at the same time call yourself agile? 1,000 epics sounds like a waterfall strategy all over again. Are we moving backwards?
Well, I have some people I know, so they are working on 200 million projects for Department of Defense. And they claim they are agile, and they are. And there is no way to shrink 200 million into 2 million, right? So if reality is big, if you have big projects, that's it. You have big projects, and you can still be agile. Because agile doesn't relate to the size, it's the way we approach the issue, right? It's not about the object, it's about how we approach it. Okay?
Great. Thank you very much, Dimitar.
Okay, thank you.